After this lesson, students will be able to solve word problems by defining one variable in terms of another and writing and solving algebraic equations. Do now. Try these two questions on your own, so pause the movie and resume when you're ready. Number 1. The sum of 4 consecutive integers is 78. What are the integers? Well, first, we need to define our variables. Let x equal the smallest integer. Since they're consecutive integers, they are in a row, so I'm going to let x plus 1 equal the second integer. And then I'm going to let x plus 2, since it's going to be one more, will be the third integer. And then I add one more and get let x plus 3 equal the fourth or biggest integer. The sum of these integers is 78. So I would add them together, x plus 1 plus x plus 2 plus x plus 3 equals 78. Combine like terms, and you get that there are 4 x's, and then 1 plus 2 plus 3 gives you 6. Isolate your x. And you get that x equals 18. Well, x, as we defined it, is the smallest integer. So, the 4 integers are 18, 19, 20, and 21. And if I were to add those up, they would give us 78. Number 2. The sum of 3 consecutive odd integers is 81. What are the integers? This means that the integers have to be odd numbers, and they are odd numbers that are in a row. So, we're going to be defining our variables a little bit differently than we have in the past. This time, we still start with x being our smallest integer. But if I were to take x, our smallest integer, and add 1, then we would be going from an odd number to an even number. Instead, we have to skip over the even number, so we're going to be adding 2. So x plus 2 would be the next consecutive odd integer. And then again, I need to skip over the even number and get to our next odd number. So I have to add 2 more to this. So we get that let x plus 4 equal the third integer. The sum of these numbers is 81. So we write our equation as x plus 2 plus x plus 4 equals 81. Combine like terms, and we get 3x plus 6 equals 81. Subtract 6. 3x equals 75. Divide by 3, and we get that x equals 25. X is our smallest integer, x plus 2, 25 plus 2, would be our second integer, which in this case would be 27, and then x plus 4, or 25 plus 4, which is 29, is our third integer. So the three integers are 25, 27, and 29. Those are the three consecutive odd integers whose sum is 81. Now let's talk about problems that involve same direction travel. A train leaves a station at 1 p.m. It travels at an average rate of 72 miles per hour. A high-speed train leaves the same station an hour later. It travels at an average rate of 90 miles per hour. The second train follows the same route as the first train on a track parallel to the first. In how many hours will the second train catch up with the first train? So we know that our first train is traveling 72 miles per hour, and that the second train travels an hour less because it leaves an hour later, but it's traveling faster, 90 miles per hour. So we need to figure out in how many hours will those two different trains travel the same distance. So we're going to begin by defining our variables. In this case, we don't know how many hours the trains are traveling for. We are going to let t equal the number of hours the first train travels. Now, since the second train leaves the same station an hour later, we know that t minus 1 is the number of hours the second train travels. We want to know when they catch up with each other, which means that the distances are the same. So we're setting up an equation where the distance of train 1 equals the distance of train 2. Well, to figure out the distance of train 1, we use our distance rate time formula, which says that the distance equals rate times time. Well, train 1 travels 72 miles per hour, and its time we defined as t, so 72t. Train 2 travels at a rate of 90 miles per hour for t minus 1 hours. Since I'm multiplying 90 times the quantity of t minus 1, we need to put it in parentheses. Now we can solve our equation. We distribute 90, so we have 90t minus 90, and that's equal to 72t. We can subtract 90t from both sides in order to get t on just one side of the equal sign. And we get negative 18t equals negative 90. Divide by negative 18, and we get 5. This means that the first train traveled for 5 hours. The second train, which traveled for t minus 1, would be 5 minus 1, or 4 hours. So the question is, in how many hours will the second train catch up with the first train? Well, it would catch up 5 hours after the first train travels. Since the first train leaves at 1 p.m., we can say that they'll catch up at 6 p.m. So the trains catch up to each other 5 hours after the first train leaves, which is at 6 p.m. Now you try this problem. Pause the movie and resume when you're ready. A group of campers and one group leader left a campsite in a canoe. They traveled at an average rate of 10 kilometers per hour. 2 hours later, the other group leader left the campsite in a motorboat. He traveled at an average rate of 22 kilometers per hour. How long after the canoe left the campsite did the motorboat catch up with it? And part B asks, how long did the motorboat travel? So we start by defining our variables. Let t equal the number of hours the canoe travels. Since the other group leader left in the motorboat 2 hours later, that means that they traveled 2 hours less. So we're going to let t minus 2 equal the number of hours the motorboat travels. Now we're setting up an equation again where the distance of the canoe equals the distance of the motorboat, because we want to know when they catch up with each other. So they've traveled the same amount of distance. Well, distance equals rate times time. So for the canoe, which travels at a rate of 10 kilometers per hour for t hours, and then for the distance of the motorboat, it travels at 22 kilometers per hour for t minus 2 hours, which we put in parentheses since that is a quantity. And now we can go ahead and solve. So we distribute to get 22t minus 44, which equals 10t. Subtract 22t from both sides. We get negative 12t equals negative 44. Now 44 divided by 12, we know that 12 goes into 44 3 whole times, which leaves us with 36. That gives us 8 remaining out of 12, which we can reduce by 4 to get 3 2/3. Now, since we're talking about hours, and we don't typically say 3 2/3 hours, we need to figure out how many minutes 2/3 of an hour is. Well, an hour has 60 minutes. So 2/3 of 60 minutes, of is a buzzword for times. So 2/3 times 60, or 60 over 1, we can then reduce, and we get 40. So this means that they traveled for 3 hours and 40 minutes. And that's referring to the canoe. So, part A, how long after the canoe left the campsite did the motorboat catch up with it? We would say the canoe traveled 3 hours, 40 minutes. And then for the motorboat, it traveled T minus 2, which would be 1 hour and 40 minutes. So the canoe traveled 3 hours, 40 minutes, and the motorboat traveled 1 hour, 40 minutes when they met up. So those two problems were same direction travel. Now let's talk about an example of round trip travel. Noya drives into the city to buy a software program at a computer store. Because of traffic conditions, she averages only 15 miles per hour. On her drive home, she averages 35 miles per hour. If the total travel time is 2 hours, how long does it take her to drive to the computer store? Hint: the distance from home to the computer store is the same distance as the computer store to home. So, what we don't know is how many hours it took her to travel to the computer store. Because even though we don't know the distance, we do know something about the distance, as you can see in the hint, which is that they are the same. So what's more significant in this problem, rather than the distance, would be how much time or how many hours did it take Noya to drive from her house to the city, to the computer store. So we're going to let T equal the number of hours it took Noya to get to the store. Since it took a total travel time of 2 hours, and it took her T hours to get there, that means it took her 2 minus T hours to get home. So we're going to let 2, the total travel time, minus T, the number of hours it took to get to the store, equal the number of hours it took Noya to get home. Distance to the store equals the same distance to her home, since it's a round trip travel. On the way there, her rate was 15 miles per hour for T hours, so rate times time gives us our distance to the store. Distance to home, her rate is 35 miles per hour for 2 minus T hours. We then distribute 70 minus 35T equals our 15T. We can add 35T to both sides, and we get 50T equals 70. Divide by 50, and we get that T equals 7/5, or 1 2/5. And as we mentioned before, we don't typically say 1 2/5 hours. So to figure out how many minutes that is, we need to know what 2/5 of an hour is. So we do 2/5 times the 60 minutes in an hour, and we find that it's 24 minutes. So this means 1 hour and 24 minutes. So, the question is, how long did it take her to drive to the computer store, which is defined as our T. It took Noya 1 hour and 24 minutes to get to the computer store. We could also figure out then how long it took her to get home, since we know it took 2 hours total, which means that it would have taken her 36 minutes to get home. Now you try this problem. Pause the movie and resume when you're ready. Suppose you hike up a hill at 4 kilometers per hour. You hike back down at 6 kilometers per hour. Your hiking trip took 3 hours. How much time did it take you to hike up the hill? Well, in this case, it's another round trip travel, because the distance up the hill is the same as the distance down the hill. What we don't know is how much time it took to get up the hill. So we're going to let T equal the number of hours it took to hike up the hill. Then, since it took 3 total hours and it took T hours to get up the hill, we know that it took 3 minus T hours to go back down the hill. Since it's round trip, going up the hill and down the hill has the same distance. So we know the distance up the hill equals the distance down the hill. Distance equals rate times time. So the rate going up was 4 kilometers per hour for T hours, and the distance down the hill is 6 kilometers per hour for 3 minus T hours. We can then distribute to get 18 minus 6T, which equals 4T. Add 6T to both sides, and we find that 10T equals 18. Divide by 10. We can reduce to get 9/5, or 1 4/5. 4/5 of an hour is 48 minutes. So how much time did it take you to hike up the hill? Well, number of hours it took to hike up the hill is our T, which we just found. So it took 1 hour and 48 minutes to hike up the hill. Now we're going to talk about opposite direction travel. Jane and Peter leave their home traveling in opposite directions on a straight road. Peter drives 15 miles per hour faster than Jane. After 3 hours, they are 225 miles apart. Find Peter's rate and Jane's rate. Hint: Since they are traveling in opposite directions, add their individual distances together to get a total distance. So with the opposite direction travel, the distances that they travel are not the same. Whereas in same direction travel and in round trip travel, we were able to set up our equation by stating that the distance of one equaled the distance of other. But in this case, they're traveling in opposite directions at different rates. So for example, if we start here and Peter starts driving in one direction, meaning that this is Peter's distance, and from the starting point, Jane travels in the opposite direction, so that this is Jane's distance, their distances are not equal, but we do know that if we add them all together, that we would get a total distance. So, let's figure out what we don't know. Peter drives 15 miles per hour faster than Jane. So we don't know how fast Jane is actually traveling. But we do know that Peter's traveling 15 miles per hour faster than her. We also do know how long they both travel, 3 hours, and we know their total distance, 225 miles. So their total distance, 225 miles. We're going to define our variables. Not t, I'm sorry, that is a mistake, because we know the time in this case, which was 3 hours for both of them. What we don't know is Jane's rate. So let r equal Jane's rate. We know that Peter traveled 15 miles per hour faster, so let r plus 15 equal Peter's rate. So now to find Peter's distance, we do rate times time. Well, his rate is the quantity r plus 15 times his time, 3 hours. So 3 times the quantity r plus 15 is Peter's distance. Plus, we're going to add Jane's distance, which is her rate times time. She travels for 3 hours at a rate of r, according to how we defined our variables. So in setting up our equation, we can say that 3 times the quantity, r plus 15, which is Peter's distance, plus 3r, which is Jane's distance, is going to equal the total distance of 225 miles. Now I can go ahead and distribute to get that 3r plus 45 plus 3r equals 225. Combine like terms, 6r plus 45 equals 225. Subtract 45. So I get that 6r equals 180. Divide by 6, and we get that r equals 30. R was Jane's rate. So now we know that Jane was traveling 30 miles per hour. We also know that Peter traveled 15 miles per hour faster, r plus 15. 30 plus 15 is 45. So Peter traveled 45 miles per hour. Now you try this problem. Pause the movie and resume when you're ready. Sarah and John leave Perryville, traveling in opposite directions on a straight road. Sarah drives 12 miles per hour faster than John. After 2 hours, they are 176 miles apart. Find Sarah's speed and John's speed. So once again, we have opposite direction travel. From our starting point, Sarah travels in one direction and achieves a certain distance from the starting point. And from our starting point, John travels in a different direction and achieves a certain distance from the starting point. We do know that they travel for 2 hours and end up a total distance apart, which is the sum of their individual distances. And we are told that this is 176 miles. What we don't know is the rates. So we start by defining John's rate as r. Let r equal John's rate, because once we define r as John's rate, we know that Sarah drives 12 miles per hour faster, so let r plus 12 equal Sarah's rate. Now we know that Sarah's distance is her rate times time. Her time is 2 hours, and her rate is the quantity r plus 12. John's distance is his rate times time. He travels for 2 hours at a rate of r. Now we set up our equation. 2 times r plus 12, plus 2r equals 176. Distribute to get 2r plus 24 plus 2r equals 176. 4r plus 24 equals 176. Subtract 24 from both sides. So we get 4r equals 152. Divide both sides by 4. And we get that r is 38. R is John's rate. So John traveled 38 miles per hour. And Sarah traveled r plus 12. 38 plus 12 is 50, so Sarah traveled 50 miles per hour. Try this one on your own. Pause the movie and resume when you're ready. 2 jets leave Dallas at the same time and fly in opposite directions. One is flying west 50 miles per hour faster than the other. After 2 hours, the jets are 2,500 miles apart. Find the speed of each. Well, these are opposite direction travel, which means that the sum of the distances that each travels will equal a total distance of 2,500 miles. From our starting point, we know that one plane is traveling west, so the distance of the westbound jet. And then we also know that there is a jet traveling eastbound a certain distance. Their total distance is 2,500 miles. We're going to let R equal the rate of the eastbound jet. Sorry about the handwriting. It seems that there is some technical difficulties here. And the jet flying west travels 50 miles per hour, so let R plus 50 equal the rate of the westbound jet. So the distance of the westbound jet is 2 times R plus 50, and the distance of the eastbound jet is 2R. 2 times R plus 50 plus 2R equals 2,500. 2R plus 100 plus 2R equals 2,500. 4R plus 100 equals 2,500. Subtract 100. 4R equals 2,400. R equals 600. R is the rate of the eastbound jet, so the eastbound jet travels 600 miles per hour. The westbound jet travels 650 miles per hour.